Okay, good morning. Welcome to
MathyMath162a.
MathyMath162a. So you started in on your geometry book today, right?
Yep.
And I saw a very cool thing from a Twitter friend of mine named Colin Wright today, and I thought it'd be a fun way to talk a little bit about geometry, because you've seen a lot of geometry already.
Yeah.
So he starts with a right triangle. I'm going to label my diagram a little different than his, but that's fine. A right triangle, ABC, and the inscribed circle. What do you know about the inscribed circle?
Well, I know that it can chop the sides into these similar lengths.
Okay, so which lengths here? Why don't you mark the lengths that are the same?
So, these are all the radius.
Okay.
This is A minus R. This is A minus R. B minus R and B minus R.
Okay, very good. Let's talk about this. Why is this length here R?
Well, because when the tangent to a circle meets the radius, it creates a right angle. I'm going to prove why it's a square.
Okay, you're going to prove why it's a square.
Yeah.
All right.
So when the tangent to a circle meets the radius, it makes a right angle.
Okay. So you're saying this is a right angle.
You know that's a right angle. We know that's a right angle for the same reason.
Okay.
And that's forced to be a right angle.
Okay, so this is forced to be a right angle.
And we know this is R and that's R, so this is R and that's R.
Okay, so we got a square there.
Mm-hmm.
Okay. Why are these two side lengths the same?
Well, because if you draw this length here, you have congruent triangles. As you have, they share this side.
Mm-hmm.
You have this side and that side are the same. And this right angle and that right angle are the same.
Okay. Good. That, by the way, also tells you that those two angles are the same, and you might remember that the center of the inscribed circle lies on the angle bisectors. And these two sides are the same.
For the same reason.
The same reason. Okay. But that's just a quick review. That's not what Colin Wright was showing. He's showing a cool new proof of the Pythagorean theorem. So what is the area of our triangle?
It's 1/2 AB.
It's 1/2 AB. I'm gonna try to squeeze this into one thing. So the area, one way is 1/2 AB. And what's another way we can think of the area?
It's the semi-perimeter times the radius.
Semi-perimeter times the radius. Okay. So what is the perimeter?
It's A plus B plus A minus R plus B minus R.
Okay. Now, you remember that formula, semi-perimeter times the radius. We can write it by, we can derive that formula by looking at these triangles. You get R squared from that square.
Mm-hmm.
This is A minus R times R, 1/2.
Times 2.
Times 2. So that's just A minus R times R, because I have 2 times 1/2.
And then B minus R times R.
Okay. So these two things have to be the same. 1/2 AB has to equal R squared plus A minus R times R plus B minus R times R. And believe it or not, that is going to tell us, that's going to give us a proof of the Pythagorean theorem. So let's take a look, okay?
Alright.